Hello students, today we are going to start the new chapter atoms and molecules. Okay, so these atoms and molecules, how did the scientists reach to these words atoms and molecules? How these words were said that they are atom or they are molecules? Okay, this, for that what happened, they took examples, okay, and they did experiments. Okay, suppose you take a piece of paper, okay, that is a matter, isn't it? Any matter, anything which you are seeing around you is a matter. Okay, so take a piece of paper, just go on dividing. Okay, a stage comes where it is not divided. Okay, so here this stage, okay, at which this can't be further divided. Okay, so it was in the brain of the scientist now that yes, matter also have the stage where it cannot be divided. Okay, it is not divisible. Okay, so then Indian philosopher Maharshi Kanad, okay, he came forward and said matter in Hindi we call it what? Padarth. Okay, he said that matter can divide, but yes, a stage comes where it can't divide. Okay, it, like the paper example I said, it went on dividing, but a stage came where it was not divided. Okay, so he said that a stage where we can't divide that atom is known as Parmanu. So this word Parmanu was given to the matter which was not divisible. Okay, now here next scientist came, Indian philosopher also he was, okay, Pakuda Katyayama. Okay, he said that these Parmanus or these particles, they combine, okay, and they form various forms of matter. Like you can see water, you can see water, any salt you can say, any oxygen gas, anything you can say, they combine. These, what happens, these Parmanus or these particles combine to give various forms of matter. Okay, then came Greek philosopher Democritus Lysippus. Okay, Democritus and Lysippus, they said what? That this Parmanu, they renamed it as what? Atom. Okay, and this atom in Greek it is known as indivisible. Okay, so atom is indivisible, they said, which was just a new version of what Maharshi Kanad has said about this matter and named Parmanu. Okay, now when these all came, okay, then these scientists, okay, they were seeing or observing what? That there is a difference between elements and compounds. Okay, and what was the difference? Okay, they were going on doing experiments to see that. Okay, then came Anthony L. Lavoisier. Okay, he gave the foundation of chemical sciences by establishing two important laws of chemical combination. Okay, actually what happened, he formulated two laws which were common in all the chemical combination reactions. It means in all the chemical reactions which were taking place. Okay, so this was said by whom? Lavoisier. These laws were formulated by Lavoisier, and he said that yes, there are two important laws of chemical combination which we are studying step by step. Lavoisier and Joseph L. Proust did number of experiments, and they gave the laws of chemical combination. Okay, two laws were given. Okay, one was given by Lavoisier and another was by Proust. Okay, and Lavoisier gave the law of conservation of mass. Okay, but how did he give? He performed experiments, isn't it? Okay, but how did he perform the experiment? He took number of things and he saw that what happens during the formation of a molecule, what happens during the formation of a new compound. Okay, for this he actually pointed out the change in mass and the chemical change. Okay, what are happening over there actually? Okay, for that one experiment to prove this law of conservation of mass, or which govern this Lavoisier to frame this law of conservation of mass, is okay. He took what, conical flask, okay, and in that he kept two solutions, that is copper sulfate and sodium carbonate solution. Actually the solution was 5% solution of the pair, this copper sulfate and sodium carbonate. Okay, he took actually this sodium carbonate in what, in the beaker, okay, and in the ignition tube he took copper sulfate solution, okay, and he tied it with the string, okay, closed the mouth of the flask with the rubber pop, okay. Naturally what happened, after doing this, he took and weighed the whole apparatus with the solution and he noted down it, okay, and then what, tilted the flask. Naturally what happened, the solution present in the ignition tube mixed with sodium carbonate. Reaction took over, okay, and new substance was formed. It was seen by the precipitate formation, okay, and naturally what happened, he weighed again the whole apparatus and saw that before the experiment the weight and after the experiment the weight, it was equal, okay. It means here the mass of the reactant is equal to the mass of the product, okay. So he said that mass can neither be created nor be destroyed in a chemical reaction, because here the mass remained the same. Actually here the reaction has taken place, and here what had happened, CuSO4 plus Na2CO3, okay, it formed what, Na2SO4 plus CuCO3, okay. And here this CuSO4, Na2CO3 are what? The reactants. What is the product here? Sodium sulfate and copper carbonate. Here the mass, when he saw this mass and this mass, it was similar. And this said that yes, the law was formulated now, the law of conservation of mass, that mass can neither be created nor destroyed in a chemical reaction. Let us see by a numerical how we prove the law of conservation of mass. Okay, in the question if it is given, barium chloride is equal to how much? 20.8 grams. Sodium sulfate is equal to 14.2 grams. Okay, and barium sulfate is equal to 23.3 and NaCl it is 11.7. Actually, what happened over here? Barium chloride and sodium sulfate. Okay, here it reacts to form BaSO4 plus 2 NaCl. Okay, so here the weight of barium chloride is given, okay, 20.8. Sodium sulfate it is given 14.2. Okay, barium sulfate it is given 23.3 and sodium chloride it is given 11.7. Just we have to see that, we have to add the reactants, the mass, take out some of the mass of the reactants, okay, and some of the mass of the products. And when we are summing up, how we do it, mass of the reactants, how we will be just adding it, isn't it? 20.8 plus 14.2 and we will be getting how much? 35 grams. Okay, now mass of the products are what? BaSO4 and NaCl. Okay, so when we add it, what we are getting? We are getting 25 grams. Here it is written the mass, we are just adding it. Okay, then we see we got how much? 35 grams. So here mass of the reactants is 35 grams, mass of the product is 35 grams. So what happens? Here the mass of the reactant is equal to the mass of the product, and yes, this reaction is obeying the law of conservation of mass, and it is saying that yes, in this the mass of the reactant is equal to the mass of the product. So here mass is neither created nor destroyed in this reaction. So this is obeying what? Law of mass, conservation of mass, which was said by whom? Lavoisier. Now law of constant proportions, okay. This was given by Lavoisier and other scientists, mainly who? Joseph L. Proust. Okay, Lavoisier and Joseph L. Proust, what they said, what? This compound is made up of what? Element plus element, maybe another element also, okay. And these elements are present in definite or same proportion, okay, by mass in a specific compound, okay. For example, okay, if we are taking water, water formula is H2O, mass of hydrogen is 1, so 2 hydrogen atoms are present, so it becomes what? 2, isn't it? 2 because the mass of hydrogen is 1, so 2 into 1 it becomes 2. Oxygen mass is 16. So here 2:16 comes, when we simplify it, it becomes 1:8. Okay. Now here we are seeing in 1 gram of hydrogen, here 1 gram of hydrogen combines with 8 grams of oxygen to form what? Water. Okay. Likewise, other example, NH3, this is ammonia, okay, nitrogen and hydrogen, okay. So here nitrogen mass is how much? 14, okay, and hydrogen it is how much? 1, but 3 atoms are present, so 3 into 1 it becomes 3. So here nitrogen and hydrogen are present by mass in the ratio 14:3, okay. So here 14 grams of nitrogen combines with 3 grams of hydrogen to form what? Ammonia. So this is specific, okay. If water is formed, 1 gram of hydrogen will be present in proportion to what? 8 grams of oxygen. If ammonia is there, then it will be 14 grams of nitrogen in proportion to 3 grams of what? Hydrogen present. Okay. Likewise, any compound if we are taking, these elements are in specific proportion, okay, and to combine and form the compound, okay. So here it was said in the second law by these scientists Lavoisier and Proust that yes, in a chemical substance the elements are always present in definite proportion by mass. Okay, so this is all for today. Good day. Take care.